Yeah, that's okay. I think I'm recording now. Rabiul, you said something? Oh, okay. Lorden, you have the wrong book. Yeah. Okay. Oh, you have the college algebra. Oh, okay, that's different then. Textbook, it's the textbook, the official textbook, it's pre-calculus, right? The fifth edition. Rabiul, you're saying it's not even. You're right, but let me go over the steps here. So first step, we have to find. Step one, you have to find f of minus x. Okay, because in the next step, we're going to compare f of minus x to f of x, right? All right, so then let's write again f of x, my initial function, right? Which is 2x squared minus x plus 1. And now I have to evaluate f of minus x. Okay, so the idea is, again, to substitute x by minus x, right? So, well, here's the expression of my function f. There's an x in here, there's an x in here. So this x now becomes minus x, and the same for this one here, it becomes minus x. So it's going to be like 2 here, this is the power 2, and the x inside the circle becomes minus x. The same for this, well, there's a minus here, and then this x here becomes minus x, and then of course there's plus 1. All right. Okay, now let's compute this thing. So it's 2. Now this circle minus x squared, as I said, you think of this circle as a parenthesis. So this is like saying we have like parentheses minus x, and then there's a square outside the parentheses, right? Because the square is outside the circle, obviously. And then there's a minus, and then there's parentheses here, there's a minus x, right? And then there's a plus 1. Okay. Now, as I said, this is f of minus x, of course. So f of minus x is equal to, so 2 times, so minus x squared, because the power is even, this is a square, of course, this is even. Okay, then it's going to be plus x squared. Okay, so this is plus x squared. And then there's minus, there'll be a plus, this minus here. See this minus, that'll be plus x. So plus x, and then there is plus 1. This plus 1 here, we're going to keep the plus 1. All right, so I got my f of minus x. Now, let's compare in the step number 2. Let's compare f of minus x to f of x. So if they are equal, then f would be even. If not, then f is not even, right?
I'm sorry, Professor, before you continue, yes. Why was the outside minus or negative? Why was it turned into positive?
Because we have 2 negative signs. So here, you mean this, right?
Yes.
So because I had minus here, oh, sorry. So I had minus here, and this is, you see this minus here?
Yes.
The same right here. So I'm gonna keep it. Okay, it's just the same. And then here inside this blue circle is this minus x, right? Because I had to change my x into my minus x, right? So I have this minus. Now the thing is, whenever you have minus, negative, that will be positive.
Okay.
So whenever you have like minus, that will be a plus.
Okay.
That will be equal to plus.
Got it.
So yeah, so this is so that's why it becomes plus, because 2 negative signs. Now, so as I said in step 2, we're gonna compare the 2 functions. So the f of x, which is the original, you know, the function given in the problem, the initial function, which is 2x squared minus x plus 1, and then my f of minus x, that's the function I got in the first step. So this is like this one here, right? which is 2x squared, and then it's plus x plus 1. Right? So now the question is, are they the same? Well, obviously there's a difference here. This is a minus, and here it's a plus. So they are not the same. They are not equal. Okay. Lorden, what are functions are not? Yes. Therefore, it's not even. Yes. So the answer is that this f of x is not even. Okay. Okay, guys. I'm gonna show you later. I mean, with this powers, I will show you how, like, without like doing all these computations, how to determine whether f of x is even or not. But of course, it's just because like in the test or in the test or in the homework, you have to justify your answer. So we have to do all these steps. Okay. But I'm gonna explain. I mean, I'm gonna show you later how to, like, in general, whenever you see a function, you can tell whether the function is even or not. Okay. So well, here's a small exercise before moving to the odd functions. So exercise. I'm gonna just give you one function. So you can just practice a bit here. So determine whether f of x equal to, let's say, so let's say 3x4 minus x cubed minus 1 is even. Okay. All right, so guys, you have, let's say, 5 minutes to think about the exercise. So please try to follow the same steps as I did in the previous example, right? So first, step 1, you're supposed to find f of minus x, and the second step, you're supposed to compare it to f of x. So if they are the same, then the function is even. Let's see. So saying yes, Rabiu, not even. Yeah, Elizabeth, it's not even. Sean, no, it's not. It's not even. So the answer should be not even. Yeah, very good, Rabiu. Liani, it's Beth. Yes, it's so yeah, it's not even. I think it's like it's raining all the time last days, right? Well, hopefully, I don't know why, but yeah, it's. I mean, last weekend it was really sad. Was okay. So Lorden, you're saying yes, very good, absolutely, yeah, very good. Not even, yes, Lorden. Um, all right. Does anyone need more time? Okay, I guess not. Um, okay, so let me go over this function here. So, well, so first step, so we're gonna find f of minus x. So my advice for you guys, I mean, if you are struggling with this notion of even function, uh, so just try to follow the steps and use the circles as I do, like when you substitute x by minus x. So for example, here my f of x is, so this is the x fourth minus x cubed, right? Minus 1. Now, you need to find f of minus x. So f of minus x. And as you can see, what you need to do is to replace x by minus x. So here's an x, here's an x. So just put a circle around x, okay? And then you replace your x by minus x, okay? So this is the, and this is power 4. There's a minus here, so I'm gonna keep the minus. There's a cube, here's my cube, and then we're gonna keep, of course, then minus 1. All right, so let's see. So this f of minus x, this is there's this 3 here. Now, we have this negative x to the power 4. And as I said, whenever you have even power, then the minus is going to disappear. So it's going to be a plus, okay? So it's just, so because, so the power here is even, okay? So then it's actually plus. Okay, so it's a plus x to the power 4. So it's going to be plus x to the power 4. And then there's this minus here. So I'm going to keep the minus. All right. And then there's this minus x cubed. Now, because the power is odd, right? It's cube, right? So this is the power here is odd. So then it's going to be a minus. So it's going to be like minus x cubed, right? Or let me probably use a purple here. So it's going to be minus. So this is going to be minus x cubed. Okay. And then there is minus or minus 1, right? Now, as I said, I mean, like in the previous example or exercise. So here we have minus minus. So it's going to be a plus. Okay, so this is now, so f of minus x is actually 3x fourth plus x cubed. Okay, because we have minus 2 minus signs, right? So it's gonna be plus. So it's plus x cubed minus 1. Okay, so again, be careful with the power. The power here is really important. Okay, if the power is even, so you can get rid of the minus. If the power is odd, then you're gonna have a minus, another minus. Okay.
So why isn't the the x cubed minus?
Well, because let me do it again here. Okay, so there is this. Okay, there is this minus, right? This there's this subtraction here. There's this minus, so I'm gonna keep the minus, right? And there's this minus again. Okay, that's our subtraction. So we're gonna keep the minus there. And then what about? So the question is, what about this minus x cube? Okay, so what I'm saying is that this minus x cube, so you see this minus x cube, because the power is odd, then it's gonna be minus again x cube.
Okay.
Okay.
Yeah.
And then because you have these two, you know, there's a minus minus, yeah, then that would be this plus here.
Okay. I got confused at what step you were converting the x to negative or positive depending on the power. I thought you did it last.
Okay. I see. Rabiu, you're saying? Oh, okay. All right. So then last step, of course, you compare. So your initial function, which is 3x4 minus x cubed minus 1 to the f of minus x, which is this 3x4 plus x cubed minus 1. And of course, if you compare these two functions, they are not equal. And so the answer, of course, f of x is not even. So these two functions here are not, they are not equal. So f of x is not even. Okay, so again, guys, just keep in mind this power rule. If you have the even power, then it's going to be a plus. If you have odd power, then it's going to be a minus. All right, so that's for even functions. Now, before the exercise, so I'm going to do the odd functions, and then we're going to have like an exercise about the even and odd functions. So for odd functions,
let me finalize that, Professor, please. Bring it down. There, give me just a couple of minutes.
Sure. So next, so it's about odd functions. Okay. Well, so I'm going to give you the definition of odd functions, but I'm going to explain why they're why we are interested in odd functions. Okay, because as the same like for even functions, we said even functions, they have a nice graph. It's a symmetric above the y-axis. They're the same for odd functions. Their graph is going to be nice in the sense that we're going to have a sort of symmetry in the graph. Okay. So, but before the graph, let me just write down the definition of odd functions. Odd function. So a function f. So function f of x is odd if. So the definition is the following: if f of minus x is equal to, so remember for even functions, f of minus x should be equal to f of x. But for odd functions, f of minus x is equal to minus f of x. Okay, so we have this minus or the opposite of the function f of x. So you have this minus outside the function f, right? Okay, so what's the idea here? Why we are interested in these odd functions? So what we are saying here is that x and minus x. So remember, for even functions, x and minus x, they're gonna have the same output y, right? Because f of x is equal to f of minus x. Now, for odd functions, x and minus x, they're gonna have opposite outputs. So x and minus x have opposite outputs, right? Because so as you can see, guys, so the output of minus x is the opposite, right? Because you have minus here, it's the opposite of the output of x, right? So let's say you have a graph. So let's see what happens when we have an odd function. Okay, so example, let me take a example. Here's my x-axis, right? And this is y-axis. So let's say this is 1, 2, 3, for example. This is -1, -2, -3. This is 1, 2, 1, -2, and -3. So for example, let's say we have the following function. So let's say f of 0 is 0, f of 1 is 2, f of 2 here is 1, and then f of 3, let's say, is 3, right? And so this is, let's say, f of x. So again, what I'm saying here, guys, is that like f of like f of 1, right? F of 1 would be, this is 1, so f of 1 would be 2, right? So f of 1 is 2, f of 2 is 1, and then f of 3 is 3. And of course, f of 0 is just 0, right? So this is like, so f of 2 here, it's 1, and f of 3 is like 3, all right? Anyway, so what we are saying here for odd functions is that x and minus x, they have opposite outputs. So for example, if x is positive 1, okay, so here's x is positive 1, and you take x minus x, that will be -1, okay? So the question is, what will be f of -1? So what we are saying for odd functions is that x, so 1 and -1, they have opposite outputs, right? So then f of -1 would be equal to the opposite of the output of 1. So if f of 1 is 2, then f of -1 would be the opposite, would be -2. Okay. For example, what will be f of -2 if my function f is odd? Well, f of 2 is 1. So then we are saying, again, x and minus x, they have the opposite image. So if x is 2, and so minus x would be -2, of course. So they have opposite image. So then f of -2 would be the opposite of 1. So that would be -1. Okay. F of -3, that will be the opposite of the output of 3, which is 3. So that will be -3. All right, etc. So let me just plot this point. So f of -1, we are saying it's -2. F of -2 is -1, and f of -3 is -3 here. Okay, so let me just connect these points and okay. Well, here actually there's a symmetry, and the symmetry is so the symmetry is about the origin here, right? So you see here the origin, the 0, 0. So at this point here, as you can see, like this point here, this one here, let me pick a different color. So let's say this point here is like the image of this one here. If you use the, so they are symmetric about the origin, right? So the origin again, guys, is just this point here. It's the 0, 0. That's what I call the origin, okay? You can see, for example, if you take this point and this one here, right? So they are like symmetric about the origin, right? Etc. So so these odd functions, they are nice because they are actually symmetric about the origin, or the you know the 0, 0. So the odd functions.
Professor,
Yes.
can you
Yes,
explain
please.
function of 3?
Uh,
Function of 3 is equal to 3, right? But how is it opposite?
yeah, f of yeah.
Like, I understand function of 1 equal to 2 and function of 2 equal to 1 is equal.
F of 1 is 2, right?
Yeah, f of 1 is 2 and f of 2 is 1.
Mm-hmm.
But f of 3 is 3.
Yes, because f of 3 is 3 because as you this is my x. This is x equal to 3, right? So if you draw this vertical line, it's going to intersect the graph at this point, which corresponds to the level, or to the y equals to 3. You see why f of 3 is 3?
Yeah, I see. Okay.
Mm-hmm. So that's why f of 3 is 3, yeah. Yeah, so I was saying, so odd functions, they are nice because they are symmetric about the origin, are symmetric. So that's why we are interested in these odd functions. So they are symmetric about the origin. Okay. So like, you know, like for this point here, this one. So you see the distance from the origin to this point. So this should be the distance between the origin to this point. Then if you take this one here, it has the same distance to the origin, right? So they are, so these 2 points, this one here and this one, they are symmetric about the origin, because you know the distance from, they have the same distance from the origin, right? From this point here. Like this point here would be like in the middle of these 2, right? This one here and this one here, right? This one and this one here. So the origin is like in the middle, right? That's what I mean by symmetric about the origin. It's like the origin would be like in the middle, you know, of the segment. Right. So that's the definition of odd functions. Now let's check a couple of functions and see if they are odd or not. So let me give you an example. So example. So let's say you have f of x. It's x cubed minus x. Okay. So we have to check. So we have to check if f of x is odd. Okay. So first step 1. So there are 2 steps. Like it's like for even functions, right? So for even functions, we had to compare f of minus x to f of x, right? So here the same thing. So first we're gonna evaluate. In the first step, we're gonna find or evaluate f of minus x. Okay, and in the second step, Well, here a little bit tricky. So we need to compare f of minus x to minus f of x. So we have to compare f of minus x, what we got in the first step, with the opposite of f of x. Okay. So don't forget, we have to compare it with the opposite of f of x. All right, so let's see. Okay, so first step. As usual, we need to find this f of minus x. I'm going to write down first. This is the function given in the problem. It's x cubed minus x. And then I need to find f of minus x. Okay, so replace x by minus x. This x here and this x here by minus x. Okay, so there's a cube here. There's a minus. So minus x becomes minus x. So here's my minus x and here's my minus x. All right. So let's see. So this is f of minus x equal to, so the first one here, because the power is odd, right? This is odd.
Stays negative.
Stays negative, absolutely. So it's it's just minus x cubed. Okay, so it says negative. And then, as you can see, guys, there is, well, here there's well, minus x. So here there's no power, right? Here the thing is we have minus, right? So two minus signs. So minus, that would be a plus. Okay, so this minus and minus, that would be a plus. So it's a plus x. Okay, minus, that would be a plus. So that's my f of minus x. All right, so now I can move to the second step and compare. So step 2. So we need to compare f of minus x to, so it's not f of x, it's minus f of x. Okay. So first, what's f of minus x? Well, that's what I got in the first step. So in the first step, f of minus x is actually minus x cubed plus x. Now, I need to compare it to minus f of x. So minus and f of x. So here, guys, be careful. So there's this minus. So here's my minus. All right. And then for f of x, you need to use parentheses for f of x, right? This f of x here. So it's going to come with parentheses. So I'm going to need parentheses here. Okay. So what's f of x? F of x, that's that's the initial function, right? That's the x cubed minus x, right? That's the here, right here. This is my f of x. It's x cubed minus x. So I'm gonna write x cubed minus x inside the parentheses. Well, the parentheses are really important because you're gonna distribute the sign. Okay. So for example, so this minus f of x is gonna be equal. Well, first, so we have minus x cubed. But then when you distribute the sign, as you can see, there's a minus here and minus here. So because of the parentheses, you distribute the sign minus, that will be a plus. Okay, so this minus, that will be a plus. Okay, plus x. Okay, so you see why the parentheses are important, because if there are no parentheses, then it's going to be just like, minus x cubed minus x, but that's not true. Because we need the parentheses around f of x, so you put the parentheses around f of x, and then when you distribute the sign, as you can see, the minus became a plus, right, because of parentheses. So, all right. So yeah, so we got the f of minus x, we got the minus f of x, and as you can see, they are equal, right? So conclusion here. So f of minus x is minus x cubed plus x, minus f of x, it's minus x cubed plus x. So again, don't forget when you compute minus f of x to put the parentheses around f of x, okay? So they are equal. Okay, f of minus x is equal to minus f of x. So then f of x is odd. Okay. All right, guys. Is there any question about? So this is for odd functions. Okay. So here's an exercise. So I'm going to give you a couple of functions, and you need to determine whether the function is odd, is even, or odd, or neither. Okay, so exercise. So determine whether the function f is even, or odd, or neither. So sometimes, I mean, actually, most of the functions, they are neither. I mean, neither even nor odd, okay? Yeah, function could be either even, odd, or neither, okay? Right, so one, number two, number three, f of x. So for number one, say it's x
Please scroll up.
squared. Oh yeah, sure. So f of x is x squared. Let's say x squared minus x. Number two, f of x is, let's say it's x to the power 4 plus x squared. Okay. And number three, f of x is, say, x cubed, say minus 1. So let's say, guys, you have 5 minutes, 10 minutes to think about this exercise. Actually, in homework number 2, we're gonna have, like, I think the last problem in the homework number 2, you have to let's see, where's the homework? Yes, so yeah, last problem. Well, actually, the second problem. There are like 2 problems in homework number 2. Yeah, so in the second problem in homework number 2, you have like 4 different functions, and you have yeah, you have to check if the function is odd, even, or neither. I see there's something in the chat. Is neither? Yes. Yeah, absolutely. First one is neither. So we are Rabiul. Yes, very good. Yes, minus x squared minus x. Yeah, that's very good. Yeah, yeah. Yeah, Elizabeth. Yeah, it's neither. Yeah. Yeah. So you have to. Yeah, absolutely, Rabiul. So you have to find f of minus x, and then you compare it to f of x, and if it's not even, then you have to compare it to minus f of x. Yeah. Mm-hmm. Eliani, your second one is even? Yes, second one is even. Absolutely, yeah. Lauren, yes, very good. Yes, Xuana. Yeah, number three is it's neither. Yep, yep. Yeah, very good, guys. Yeah, absolutely. Yeah, Tiffany. Yeah, three is neither. Yeah. And yeah, guys, number two is yeah, yeah, that's why. Yeah, very good, Rabiul. Thank you. Thank you. I appreciate it. Thank you. And actually, guys, of course, in the test or in the homework, you have to justify your answer, right? So you have to, find this f of minus x, etc., etc. But let me say the following. Actually, there is a way, like, um, if you just check the powers of x, you can tell if the function is odd or even or neither. So for example, you said, guys, like for number one, it's neither, right? I think all of you agree that the first one, it's neither. Uh, so actually, if you check the powers of x in number one, so we have an even power, right? There's this so there's this even, there's an even, sorry, let me pick a blue here. So there's an even power, that's, I mean, x squared, we have an even power, and there's x, which is, well, x is, when you have x, it means like you have x to the power one, okay? So you see here in number one, you have an even power and you have an odd power. So whenever you have like a mixture of odd and even powers, then the function is neither, okay? Because we do have an even power and odd power, okay? So if you have both of them, even and odd, you have a mixture of even and odd powers, then the function is neither. For number two, as you can see, the powers are both, all the powers are even, right? We have power 4 we have power 2. So if all the powers are even, then the function f is even.
No, you confusing me.
What about number 3? Well, number 3, is there any guess for number 3? So number 3, I think in the answers in the chat, I think all of you said for number 3, yeah. So it's not odd, and actually it's not even. So it's neither. And well, if you check the powers, well, here this is odd power, right? What about 1? Do we have a power of x there? Well, the thing is, when you have 1 or you have a constant, I mean 1, you can say 1 is actually x to the power 0, right? Because when you have a non-zero number power 0, that's equal to 1. So 1 is actually x to the power 0. So in number 3, we have an odd power and we have an even power because 0 is even. Okay. So we have a mixture of powers here. 3 is odd and 0 is even. So then the function is neither. Okay. So I mean, this is
But
like
if there's, how is 2 even if you just said that if the powers are mixed, that is neither?
where in number 2?
Number 2.
No, number 2 both are even. 4 and 2 are both are even, right? So if all the powers are even, then the function is even. If all of the powers are odd, then the function is odd. But then if you have both, I mean, if it's a mixture of even and odd, then it's neither. You see what I'm saying? All the number 2, all the powers are even, right? 4 and 2 are both are even, right? So all the powers are even, then the function is even. If all the powers are odd, then the function is odd. But like in number 3, the powers here, they're not all of them. They're not. I mean, we have 3, which is odd. That's good. But then 1 here, it's actually is like a x to the power 0, right? Because x to the power 0 is 1. So we do have an odd power and also an even power, which is 0. So that's a mixture of them, right? So then it's neither. Does it make sense?
None of this
So
makes sense, to be honest, but you could keep going.
no. But for number 2 or for which one? So what I'm saying is, if all the powers are even, like in number 2, what are the powers in number 2? 4 and 2, right? So both of them are even. So then the function is even. For number 3, what I'm saying is, like you have, x cubed minus 1, but I said 1, you can write it like as x to the power 0. So here we have odd and we have even powers. Okay, so then it's neither.
Could you like work out the first one, like actually write it out?
Yeah. I'm gonna do it, sure.
It's the only one I didn't get.
Yeah. So for number 1, okay, let me do number 1. So f of x, it's x squared minus x. Okay. So first, I need to find f of minus x. All right. So well, let me write down f of x again first. So let's say this is so here's my f of x again, x squared minus x. So I'm gonna try to evaluate f of minus x. So let me put minus x here. So this x here becomes minus x. So this is actually, this is minus x here, and there's a minus x here. There's a square, and there's also this minus here, right? There's this subtraction here. So then, okay, let me just, there's this minus here. Okay, so then f of minus x. So the first one, you have minus x squared. So the power is even, so that would be a plus. Okay, so that's actually x squared. And then here, the second one, well, we don't have a power. It's just a minus x, there's no power. But the thing is, there's minus minus, so that will be a plus, right? This minus and minus here, that will be a plus. Okay, so that's a plus, plus x. Oops. Okay, so it's a plus x. Okay, so then that's my f of minus x. Now, in the step, so in the step number 2, I'm gonna compare, oops, come on. So in the step number 2, so I'm gonna compare f of minus x to f of x, okay? And then, so if they are equal, of course, the function would be even. Otherwise, I'm gonna compare f of minus x to minus f of x. Okay, so let's see. So what's f of minus x? Well, f of minus x, we just said, this is from the first step, and we said it's x squared plus x, right? And I want to compare it first to f of x. That's my initial or original function. So my original function is just x squared minus x. Okay. So from here, if you compare these two functions, well, they are different. So then, so they're not equal. Okay, so if they are not equal, then f of x is not even. Then now I can compare f of minus x to minus f of x. So f of minus x, again, it's just from
Well,
the first step.
why do you have to compare it?
Well, to say if they are if the function is odd or not. Because if they are equal, then the function would be odd.
But you just found out that it's not odd. You said it's not even.
No, I said it's not even, but it doesn't mean it's not odd. Okay, it's not even. Now I'm checking if they are if the function f is odd. Okay, so I'm gonna compare f of minus x to not f of x. I'm gonna compare it to minus f of x. So if you want to find out if the function is odd, so I need to compare it to minus f of x. So then minus f of x would be, so this minus here will be this one here. And then, as I said, for f of x, we're going to need the parentheses. So here's my parentheses. And inside the parentheses, I'm going to put the f of x, which is, that's my, my f of x is this one here. Right here, which is x squared minus x. So let's see, this is, so it's going to be equal to, so minus x squared, and then minus minus, distribute the sign, minus minus, this minus here, and this minus here, that will be a plus. So plus x. Okay. Okay, so then now, is f of minus x equal to minus f of x? Well, as you can see, this is x squared plus x, and this is minus x squared. There's a minus x squared here, right? That's different from this one here. Here it's plus x squared. Here it's minus x squared. So they are not equal. So f of minus x is not equal to minus f of x. So then f of x is not odd. So f of x is not odd. So the conclusion is that the function f is neither. Okay, so conclusion, find answer, f of x is neither. Okay. So just be careful, guys. I mean, so if you want to check if the function is even, right, you have to compare, as you can see here, you have to compare f of minus x to the f of x, the original function. But to check if f of x is odd, you need to check, you need to compare f of minus x. You need to compare to minus, there's this minus here, right? Minus f of x. Hey, is there any question, guys, about this? I mean, this is the function here first. And as I said, you can tell just from the powers. So function f here, we have x squared and minus x, which is power 1. So we have even and odd powers at the same time. So if you have even and odd powers at the same time, then it's neither. Okay. And if all the powers are even, then the function is even. If all the powers are odd, then the function will be odd. Right? But in the test or in the homework, guys, you have to you have to do all these steps. Okay, you have to justify your answer. Okay, I can. I don't know. I don't know if I need to do the.
Do them.
Let's see. The probably. Which one you want me to do?
Do
The
all
Dari?
of them. Do
all of them? Okay. No, that's the thing, Lorden. The power is not. That's not. Well, I mean, it's not real. It's not justification. You really need to do all these steps. Okay. Yeah. So you really have to justify your answer. All right. So next we have the x fourth plus x squared. Yeah, you can use to check your answer. Absolutely, that's the idea. Yeah. So for number 2, you have this. You have this function f of x, which is x fourth plus x squared. All right. So then first step. So you do f of minus x. So that's so that will be minus x to the power 4 plus minus x squared. Okay, so that will be equal to, as I said, so minus x to the power 4. 4 is even, so that's a plus x fourth plus minus x squared. That's even again, so that's a plus x squared. Okay, so that's my f of minus x. Now in the step number 2, I'm gonna compare first to compare f of x to f of minus x. Okay, and then so f of x is x fourth plus x squared, and f of minus x is just well, this one here from the first step. It's the same thing. It's x fourth plus x squared. So they are equal. So if f of x is equal to f of minus x, then the function is even, right? So this is an even function. So answer f of x is even. Okay. If the function is even, it cannot be odd, okay, or neither. I mean, if the function is even, then you are done. You don't have to check if the function is odd or not. Okay, so it's even. It cannot be odd. Okay, or neither. For number 3, so it's f of x. I think it's x cubed minus 1, if I'm not mistaken. So again, same thing. The first step, you have to find f of minus x. So just replace x by minus x with the cube, and then there's this minus 1. So we're gonna just keep the minus 1. So then f of minus x is just this is odd power minus x cubed. I mean the cube is odd, right? So this is minus. We're gonna keep the minus, right? Because the odd power. So it's minus x cubed minus 1. So that's my f of minus x, and then we just compare in the second step. First, I'm gonna compare it to f of x to see if it's even, right? So compare f of minus x to f of x. Okay, so then f of minus x is, that's what I got in the first step, minus x cubed minus 1, and my f of x, that's the initial original function, right? The original function was x cubed minus 1. Okay, so of course you can see there's a difference here. This is minus x cubed, and here it's plus x cubed. So they are not equal. So then the function is not even, not equal. So f of x is not even. So if it's not even, then I have to check if it's odd, right? So it could be odd. You know, if it's even, then of course, if it's even, then you're done. And then the answer would be even, right? It's not. If it's not even, then we need to check if it's odd. So let's see if it's odd. So to check if it's odd, so we need to compare. We need to compare f of minus x to minus f of x. So what's f of minus x? Well, that's what I got in, again, in my first step. It's the same thing here, minus f of x. So that's minus x cubed minus 1. And then I need to compare to minus f of x. So minus f of x. So I got this minus here. So here's my minus. And then I'm going to need the parentheses for f of x. So I'm going to write f of x inside the parentheses. So what's f of x? F of x is my, original function, which is x cubed minus 1. So here's my x cubed minus 1 inside the parentheses. Now that'll be equal to, and then distribute the sign. So minus x cubed. And then again, because of the parentheses, this minus here and this minus, so minus minus, that will be a plus. Okay, so it's plus 1. Now you compare minus x cubed, that's good, but then you have minus 1 and plus 1, so that's different, right? So not equal. So this is not equal. F of minus x is not equal to minus f of x. Again, guys, that's different from odd. Odd we compared to just f of x. In the odd, in even, in the to check if it's even, we compare to f of x. When it's odd, to check if it's odd, we compare to minus f of x. Okay, that's the difference, right? So again, they are not, so it's not equal. So then f of x is not odd. Okay, so then the conclusion, of course, is that f of x is neither. Okay. I guess, yeah, so that's for even and odd functions. Is there any question, guys? well, yeah, so in the test or in the homework, you have to justify your answers. So you have to go over all these steps. Okay, and you can, as I said, you can use this powers trick to check your answer, but it's not a justification. All right. Okay, so if there's no question, let me just check the chat if there's anything. Okay, there's nothing. All right, perfect. So then, yeah, that's it for even odd functions. What else? Yeah, we need the local maximum and local minimum. Okay, so next, so after even odd functions, next we're gonna need. So in this section we have this notion of local minimum and local maximum. So next, so we are done with the even odd functions. So you know the definition, you know how to check when a function is even or odd. So next, it's a local maximum and a local minimum. Okay, so yeah, so what's a local maximum and what's a local minimum of a graph or of a function f? So it's like, I mean, local maximum, I mean, when you say maximum, it means like it's like you know, the largest value, right? Or like that would be, largest value would be like the highest point in the graph, right? And minimum would be like, you know, if you think of a minimum, well, that would be like the lowest, you know, lowest point in the graph, right? So let's start with the maximum. Okay, so local maximum, let me just write down here the definition for you. But then we have to be careful here because there's this word local. So it's not exactly, when you say local maximum, it's not exactly the highest point in the graph. So I'm going to give you a couple of examples and you'll see. So f of x has a local maximum, let's say at x, some input x equal to a, if there's a neighborhood. So we have a local maximum at a, at x equal to a, if there is a neighborhood, let's say I of a. So this is a neighborhood of a. Okay, a is it's your input x, so x is equal to a. So we have a neighborhood of a. You know, says that f of a would be larger or equal than f of x for any x in neighborhood I of a. So for any x in neighborhood I of a. Okay. So the idea is, so you have so let's say you have a somewhere here. This is your a, x equal to a. Okay, this is your x-axis. This is your x-axis. And what I'm saying here, guys, is that, so you have the graph. So you have the graph of your function f. So this is your function f here. Okay, let's say this is a graph of f of x. So f of a would be like, so f of a, this is a here, f of a would be like this point here. So this is f of a, okay? Now, as you can see, guys, if you take a neighborhood I of a, so a neighborhood of a here, if you take small neighborhood here of A, okay, then f of A, this point here would be the highest. Can I read my definition? Yeah, sure. So I'm saying f of x has a local maximum at A, x equal to A, if there's a neighborhood I of A. So what I mean by neighborhood I of A is like a small interval about A, says that f of A would be larger than f of x for any x in the neighborhood I. Okay, so the neighborhood is this. You see, this is like a small. This is like a neighborhood of A, right? And as you can see, guys, like if you take a neighborhood of A, then f of A would be like the highest. As you can see, f of A. This is f of A here, right? So f of A would be like the highest point in this small neighborhood of A, okay? So this is the highest point in a neighborhood. In the neighborhood of A. Okay. So we have like a sort of like a parabola, right? A parabola which opens down, right? And the vertex like of the parabola would be like f of A, right? This one here, this point here. Okay. So the idea, guys, is that whenever you have like a parabola which opens down, like this here, okay, then this point would be a local. Then this point would be a local maximum. So here we are using the word local because it's a maximum, but like in just like a small neighborhood of A. So for example, so this point here, this is a local maximum. Okay. Now, if I have, let's say, here's an example. So let's say we have the following graph. This is 1 here, 2, 3. This is -1, -2, etc. And let's say we have the following graph. So let's say we have, yes, if it's flipped, then it's a local minimum, yes. So yeah, so let me just give you an example here so you can see, because there is a difference. So here, okay, right? So let's say here, this is f of -1, and this is let's say f of 2. Anyway, so this is my f of x, and this is my f of x. And let's say you have to find local maximums of f of x. So local maximum of f of x. Okay. Yeah. So at x equal to 2. So first you have the highest point of the graph, of course, would be this one, right? This point here. This would be the highest point of the graph. So that's obviously it's a local maximum because like it's the highest one, right? So this is actually it's not just a local maximum, it's a global maximum because it's like the highest one, like the highest point in the whole graph, right? So it's not just a local maximum, it's actually a global maximum. Okay, so this point here, it's a local maximum, but it's actually better than local maximum. It's a global. It's actually a global maximum. Actually, a global one. Okay, because it's like the highest point of the graph. Okay, and now we also have another local maximum, which is this one, this point here. This is a local maximum because if you take a small neighborhood of -1, this is my -1, right? So if you take like a small neighborhood here of -1, then the point here at this one here, well, this point would be like the highest one, but it's not the highest one like in the whole graph, but it's going to be the highest one in a small neighborhood of -1, right? So this point would be a local. It's not a global. It's not a global maximum because it's not the highest one in the whole graph, but it's going to be a local. It's a local maximum. Okay. And anyway, so in both cases, as you can see, guys, if you have like, you have like a parabola which opens down, right? You have a parabola here, like sort of parabola which opens down here, same. Then the vertex like of the parabola would be your local maximum, right? So so the answer here, local maximum of f of x. So we're gonna have local maximum at, of course, at x equal to 2. And that's actually, it's not just a local, it's a global maximum, right? It's actually a global maximum, and also at x equal to -1. So this one here, it's a global maximum. Okay, so that's why we use this. So this word local, it means like it's a maximum, but it's not maximum like for the whole graph, but just in the neighborhood of the, in a neighborhood of the point. I see there's a question in the chat. Yes, for the point. Yes, review, yes. Yeah. So yeah, so that's what I mean by a local maximum. Is there any question, guys? You see what I mean by this local maximum? Now for I mean for local, yes, please. You are breaking up actually.
Confused about the whole. Yeah.
Devraline, right?
I'm still confused about the entire concept that you just.
The local maximum. Yeah. So the idea is, as I said, to have a local maximum. Yeah, local maximum. Yeah. Okay. So a local maximum, it's like the highest point, but it's a local. So it's like a highest point in a small neighborhood of a point. So you see, this is my neighborhood, the neighborhood of the point, the red point, right? I have this red point. You see this red point here? Okay. This is my red point, and you see this blue thing here? This is my like a small neighborhood around the point, right? That's like a small neighborhood around the point. And then what I'm saying is that this red point, this one here, this is a local maximum because it's like the highest point in this blue neighborhood. All right, so it looks like it looks like a parabola, right? And the vertex of the parabola is your local maximum. So all I'm saying is, like, if you have a graph, so if you have a graph, like I don't know, like let's say this one here, okay? So whenever you see like, like a parabola, like here, there's a parabola here, there is a parabola here, right? There is a parabola here, and then the vertex of the parabola would be like, let's say this one here, this point, and this one here. You can see, the yellow points here, these yellow points, they are like the highest points in neighborhood. So this blue neighborhood here, you see this blue neighborhood? Then the yellow point, this one here, oops. This one here would be like the highest point in this small blue neighborhood. Same here, right? This one here, this blue, this yellow point is going to be like the highest one in this blue neighborhood, right? This one here, this one. Okay. So the idea is whenever I have a local maximum, it's going to look like, so it's going to look like a parabola, and then the vertex of the parabola, so like the highest point of the parabola, that will be your local maximum. Okay. So all these 3 points, all of them. So this one is a local maximum. This is a local maximum. This is also local maximum, right? And same for this one. It's also local maximum, right? But then the thing is, you see this one here? This is like the highest point of the whole graph. So then this point would be like the global one, the global maximum. That's the global one, because that's like the highest point in the whole graph. Okay.
So the way I understand this is,
excuse me?
The way that I'm understanding this right now, can you hear me clearly?
Yeah, I can hear you now. Yeah.
So the local maximum is the highest point before it starts decreasing. That's the way I see it. Because
it's not,
you mark it and then it goes down, and then it goes up and then it goes down again.
Yeah, it's like yeah, it goes up, but then it's gonna go down, right?
So am I wrong for understanding it that way?
No, it's not. Yeah, it's not quite true. Okay, so what I'm saying, okay, so let's say you have this parabola, and let's say you have this line, okay? I'm gonna take this point, and I'm gonna take this one. Okay, my question for you is, this point here, do you think this point here would be a local maximum?
No.
Why is that?
Because it's not the highest point.
Yeah, right, because if you take the point just right after him, like if you take this point here, would be higher than the red one, right?
Yes.
So it's not. Now, what I'm saying is, if you take points in the neighborhood of this red one, then the red point would be always the highest one.
Okay, I got it.
You see, and it's just and this is just in a neighborhood of the red point. So I'm not like checking the whole graph. I'm just checking like a neighborhood of the red point. So I'm looking at just a small neighborhood around the red point, right? Now, if you're gonna check the whole graph, like like here, this one here would be like the highest point, like in the whole, for the whole graph, right? The red one, right? And that would be a global. That's what I call a global maximum. That's like the highest point of the whole graph. But the local maximum, that's another story. It's like just you take a small neighborhood around the point, and it would be the highest one in that small neighborhood. Does it make sense now?
Yes.
Okay, but you can see the difference, right? I mean, like between this parabola and this line, you can see the difference, right?
Yes.
Why this one, it would be like the highest point in the small blue neighborhood.
Yes.
Okay, perfect. Anyone else confused about this local maximum?
So all of the peaks are the answer.
Yes, all the peaks. Yeah, that's the yeah. You can say you can say it's like all the peaks. Yeah. So yeah, you have like a you have like a parabola, like yeah, and the vertex of the parabola would be like the local maximum. Okay. Anyone else confused about this local maximum?
What if like the graph keeps going upwards, like it has an arrow saying it's going to keep going?
That's a very good question, and that will be my next example, or probably my next. That's a very good point, because so what you are saying is like, if you have something like this, right? Or okay, or let's say just yeah, like in this case here, right? Because the graph here, it doesn't stop. I mean, it continues all the way up. Here the same, it continues all the way up, right? So then there is no, actually there's no global maximum, and also there's no local maximum. Okay, so here in this case, there's no local maximum. And obviously there's no global maximum, because because if you say, well, this point is my let's say, where is it? If this point is my it's my global maximum, well, then I would say, well, my graph is supposed to continue here, and so I would get like higher points, right?
Professor, I have a question.
Excuse me?
I have a question.
Yeah,
Is
please.
it possible to have global minimum or no?
Oh, yes. Yeah. Global minimum. Yes, absolutely. Yeah. So so as you can guess, so that's for a local maximum. So for local minimum, we're gonna have the opposite, right? So it's like so let me just write down for you first the the definition for local minimum, and then we can discuss some examples. All right, so for local minimum, it's just the other way, of course. So f of x has a local minimum at x equal to a if there is a neighborhood or an interval about the a, or a neighborhood, there's a neighborhood I, neighborhood I of a, neighborhood there's an extra O here, neighborhood I of a, all right, says that f of a would be less, f of a less than f of x for any x in the neighborhood I of a, for any x in any neighborhood of a, for any x in this neighborhood, the neighborhood I of a. Anyway, so the idea is that, okay, so you have like something like this, which is like a parabola, which opens up, right? And then you take this point here, this one, oops, you take this point, and as you can see, this point would be, if you compare to other points in a neighborhood, in a small neighborhood around the point. So if you take these blue points and you compare them to the green one, well, the green one, of course, would be the lowest one, right? So so in this case, so this point would be a local minimum, okay, because it's the lowest point in a neighborhood, in a small neighborhood, right? So like in this small neighborhood, right? So if you compare to any other point in this blue neighborhood, well, then that point would be like the lowest one. And of course, now if you have like a whole, if you have a graph, so here's an example. So if you have a graph, for example, so let's say we have the following graph. So let's say you have something which looks like this, all right? And you want to find, let's say you want to find the local minimum. Okay. Well, well, first, let me just put some numbers here. So let's say this is This is a -4. This is, let's say here it's +1. And let's say this one here, it's +5. Anyway, so the point here, guys, is that, so for example, if you take, the lowest point here in this whole graph, of course, would be this one, when x is +1, I say this point here, right? So this point, well, would be the a local minimum, of course, but it's also a global minimum, right? This one here, this is actually, it's a local minimum because it's the lowest point in the graph, but it's also, so a local minimum, but it's actually, it's a global one. It's a global minimum because it's the lowest point in the graph. Point in the graph. Okay, so it's not just a local minimum, it's actually a global one because it's the lowest one in the graph. Now, do we have other local minimums? Yes. For example, so if you take, so you take this one here, this point. So as you can see, this point here would be the lowest one, not in the whole graph, but just if you take like a neighborhood, if you take a neighborhood of the point, right, like this neighborhood here, and if you take any like a point in this green neighborhood, well, then the blue one would be like the lowest one, right, in the green neighborhood. Okay, so that's what I call a local minimum. So this one here would be a local minimum. So we have a local minimum at x equal to -4. And finally, there is another local minimum, as you can see, at +5. So you can here +5, this point here. And again, the same story. If you take a small neighborhood around the blue point, then the blue point would be the lowest point in the yellow neighborhood, right? That would be the lowest point in the yellow neighborhood. So that point would be the would be a local. This is a local minimum. And so, and the answer would be here. So find local minimums. So we're going to have local minimums at x equal to -4, at x equal to +1, and at x equal to +5. Anyway, guys, probably time is actually over. So I'm gonna stop here. So tomorrow we will have some exercise about the local minimum, local maximum, and then we'll try to finish this section. All right, guys. Please don't forget your homework number 1. It's due tomorrow night, before midnight, actually. All right. Thank you, everyone, and good night.
Professor.
See you tomorrow. Take care, everyone.
Right.
Thank you, Professor. Bye.
Thank you, guys. I appreciate it. See you tomorrow.
Have a good night.
Good night.
Good night.
Good night. Thank you, guys.
Thank you, Professor.
Thank you.
It logged me off. So I had to log back in. That's why I just came back into the class. Just
Oh, okay. No problem. No problem.
all right. Thank you. Have a good night.
Good night. Thanks.
Professor, I turned my homework in already.
Excuse me?
I turned my homework in.
Oh, you turn. Okay. Perfect.
All right.
Thank you. Thank you. I appreciate it. Thanks.